been to Cern in Switzerland?
I have.
For people listening, can you explain what Cern is?
So CERN, which basically stands for Conseil Européen pour la Recherche Nucléaire, basically means the Commission, European Commission for Nuclear Research. So in essence, I can make it a really short answer and say it's one big place where they do nuclear research or physics research. And give you a slightly longer answer is that really it's a bunch of scientists who set up this multinational institution to explore a better understanding of what matter is and what we're made up of. So, you know, if we're driven, I think, as humans to learn more about our world. And whether it is, okay, you know, 500 years ago, we have, you know, the sailors, I wanted to explore the other side of the ocean. What's on the other side of the ocean? You know, people were going into Africa. We did, you know, the old cliche dark Africa, you know, I want to explore what fun that is. And then we've got, you know, aspects of nature and how, you know, what is the fundamental reason why we have living things the way we do. We have Charles Darwin and, of course, the discovery of, you know, DNA and so forth. And in terms of physics, we're dealing with, or what is the matter that we're made up of? And, you know, if we boil it down, what is it made of? And so CERN is just one progression step of that in terms of a better understanding of how it works. So in a simplistic term, the way that we often understand what matter is made up of is to smash it. So hit it with particles and smash it up and see what those particles look like when they come off. The discovery of the electron was basically that, you know, basically firing a beam and watching it, what happens to it. CERN is just magnifying that. So in essence, CERN is not just the Large Hadron Collider. A lot of people think that CERN is just that large ring. CERN actually existed since 1954 with different particle accelerators or particle colliders. And the idea, again, is fire particles at matter and see what sprays off. And if you look and measure what sprays off, you can understand what the structure is that you were smashing it into.
So, yeah. So what is the Large Hadron Collider?
The Large Hadron Collider, yep.
How do you say it?
Hadron.
Hadron.
Yeah. But I'll explain that. I'll explain that.
What does that mean?
Okay, so Large Hadron Collider really is a part of the institution of CERN, which is basically in French, the version of the European Commission for Nuclear Research.
Okay.
And in essence, CERN is a physics institute that was set up in the early 50s and supported by a number of member countries, basically based in Europe. And the idea with CERN is to understand what matter is. So really what drives CERN and drives any scientific endeavor is discovering more about our world and how it works. So, you know, you've got, of course, in the 1500s, you've got the sailors moving across the oceans. What's on the other side? You've got the astronomers looking up to the sky. What is making up the stars and how does it move and so forth? And, you know, we've got Newton, for example, and understanding, you know, their understanding of gravitation and so forth. You know, you've got scientists like Darwin with how life evolves, and you've got scientists like Watson, Crick, and others who looked at, well, what's the fundamental nature of, you know, life, the DNA aspect. And so with physicists, their understanding is, well, what, particularly with particle physicists, is what's the fundamental nature of matter? You know, we boil it down to atoms, but then we say, well, hold on, we discover that atoms are made up of other particles, and we call them protons and neutrons and electrons. Well, that was discovered in the early part of the 20th century through experiments that are often referred to as scattering experiments or collision experiments. And how that all works is, you know, obviously that drives what scientists to know more. But then what happened is that they discovered that when they were looking at particles and you know, basically seeing their behavior in certain experiments, they discovered there are a whole bunch of particles that could not be explained by using that idea of, you know, an atom is made up of a proton, a neutron, and an electron. And so the quest was driven to say, well, can we learn more about what the proton and the neutron is, for example? Are they what we refer to as fundamental particles? Are they truly indivisible, right? Or are they themselves made up of smaller particles still? And so Cern developed a whole series of what we call particle accelerators or scattering experiments, which basically is really simple. You know, if you smash things together and we're able to watch the particles that come off, then you have a better understanding of the conditions of what you were smashing. You know, it's sort of like, it's a poor analogy in one sense, but it's basically a let's say an investigator in a car crash. You know, they don't see the car crash. All they see is the particles strewn everywhere. But if you analyze the particles, then you can work out how fast was that car going? What was the other car doing at the time in the collision? Right? So by looking at the remnants of the collision, you can have a better understanding of what occurred at the collision and what was involved in the collision. And that's really what particle accelerators do. But in this stead, we're not smashing cars together. We're smashing particles together, such as electrons, such as protons, and then seeing what comes off. And then as a result, you can get an understanding of what makes up those particles. So the more energy you put into the system, the more energy you can smash those particles, the more understanding you can have about what you're investigating. So in the case of the Large Hadron Collider, which is basically the largest particle accelerator in the world, it's basically smashing protons together and then seeing what comes off that. And when you measure what comes off that, you have an understanding of what, well, first of all, what the protons are, but also what is the fundamental nature of those protons. Now, this is where the term comes in. A proton is simply what we refer to as a generic term of a hadron. So a hadron is basically a type of particle we now know that is made up of what we refer to as quarks. You may have heard the term before, quark or quark, but in essence, we know that a proton and a neutron are made up of quarks, and both of them are made up of 3 quarks. And so anything that is made up of quarks is called a hadron. And so that's why we call it the Large Hadron Collider. We could call it the Large Proton Collider, but it doesn't have to be a proton. It could be something else. But it's using a proton because protons are easily produced. Basically, hydrogen is our main source of protons. So just a gas of hydrogen gas is, you know, basically all that is injected into the Large Hadron Collider, because basically that's what the hydrogen is, a bunch of protons.
And what's the scale of this thing?
Okay, yep. So again, Cern is a very large place, but the Large Hadron Collider itself is a ring that is buried 100 meters under the ground. The ring is 27 kilometers in circumference. And in that you have these 2 beams of protons spinning around at close to the speed of light. And they're at 4 points on that ring are what we call particle detectors. So the 2 beams are in 2 separate tubes going in opposite directions around this 27 kilometers track. And there are basically bunches of protons spinning around. Now, the numbers are mind-boggling. So each bunch that spins around contains about 100 billion protons, right? And you got another 100 billion protons going in the opposite direction like this. Now, it's not just one bunch, but there's actually a whole series of bunches separated about 7.5 meters around the tube. And then they spin so fast that they go around that ring 11,245 times per second. So,
oh my God.
Yeah, it's pretty fast, right? So the number I always like to quote is, okay, they travel at the speed, just shy of the speed of light, 99.9999991% of the speed of light. Now, to give you a perspective of how fast that is, if you were to run around the world at that speed, you could go around the world 7.5 times in 1 second. So you know, it's incredibly fast. So what happens is that those particles are now traveling so fast. When you smash them, and this happens at what we call detectors, and there are 4 of them on the ring. They basically make these 2 paths crossover, so that these 2 bunches now meet at the detector. And then hopefully these bunches will have some collisions of these protons. And of the 100 billion coming one way and about 100 billion going the other way, you may get only 1 billion collisions in that around, or even less, right? You don't get many collisions going on. But when they do happen, like the car crash, you can measure what comes off it. And those detectors are basically glorified machines that measure how fast they're going and what direction that they're going of the particles. And if you can measure that, then you can, well, work out what's going on here in terms of what the collision entails. And so in essence, you know, it's a better understanding of how matter works. What's the nature of matter?